We have some data here about the blood pressures of men in a certain town, and they tell us that the blood pressures of these men is normally distributed. So that means it's going to show that normal curve that has a mean of 135 and a standard deviation of 5. So remember, the mean is going to be, since this is normally distributed, this would also be the median and the mode. Basically, this is the average, right? And standard deviation tells us how far out they are, how spread out they are. So we're going to use the empirical rule to figure out how many people are in between or in the middle 68% of males in this town. So remember our Greek letters here. This is the Greek letter mu, and it means mean. So it's just instead of writing mean every time, they just gave it a variable. And so anytime you see that variable, it's like a U. So imagine that you're writing a U, but then think way back to elementary school when you learned cursive, and imagine that you write like a cursive U that has that little tail on it. That's mu, okay? And that means mean. And then this other one here is sigma, and it's kind of like a squished 6. You can write it either way. See, I write it either this way or this way, and my sigmas are not fantastic. They all look a little bit like a 6. But anyway, that's a Greek letter sigma. Nope, that one's really bad. Let's try this one. Greek letter sigma. Ooh, that one's beautiful. I should take a picture. And that means standard deviation. Okay, so anytime you see that, if it just says mu equals 135, sigma equals 5, then you just know that means mean, and this means standard deviation. Okay, so we're going to draw a picture, and I already have this picture drawn. So here's our normal curve, and we're going to label our normal curve. So what you can do on your own paper is you can just, sketch out a quick normal curve, right? And then you can say, all right, here's the mean, and then here's one standard deviation away, and you could even do it in different colors because you're so artistic, except for I didn't switch colors there. Okay, there's one standard deviation away, and there's 2 standard deviations away, and there's 3 standard deviations away. So you could draw your own little normal curve. It doesn't have to look perfect. And then you could just label it. So you could say, well, the mean is 135, and then one standard deviation up would be 140, and one standard deviation down would be 130. So this would be 145 and 125, and so on and so forth, right? So I already have it drawn here, but I want you to realize that you can draw your own. You don't have to have some fancy normal curve ready, right? Okay, so remember, the empirical rule tells us that within one standard deviation of the mean, we're going to have 68% of our data. So in this piece, we're going to have 68% of our data. Remember, within 2 standard deviations of the mean, we're going to have 95% of our data. And within 3 standard deviations of the mean, we're going to have 99.7% of our data. That's why sometimes the empirical rule is called the 68, 95, 99.7 rule. I know it just rolls off the tongue. But anyway, so we're looking at 68%. So 68% is this first standard deviation, right? Where we're just looking at one standard deviation away from the mean. So that would be in between 130 and 140 is where we could expect about 68% of men's blood pressure to fall.